All right, here we go. So I'm going to go over questions 1 to 63 in this video. I'm going to go pretty quickly, and one of the things I want to stress here is that you should be able to do these 63 problems in less than 30 minutes. Less than 30 minutes. I actually have a bunch of them grouped up, and then I'll say, hey, you should be able to do this chunk in 2 minutes or this chunk in 5 minutes, because that's how I did it. I timed myself with each group, with each set of pages, and I'm going to kind of just run through them real fast. So here we go. If you haven't done 1 to 63, now might be a good time to pause this video and go ahead and do them and test yourself first. First is 1 through 11. It took me 3 minutes to do 1 through 11. And this is all just nomenclature stuff. When I see barium sulfate, I see an ionic compound because that's a metal and a nonmetal. So I grabbed the charge for barium, and then I know sulfate is SO4 minus 2 and made the formula. Then I saw CuSO4, that's a metal and a polyatomic ion, and that metal's a transition metal, so I have to have a Roman numeral on there. So I worked out the Roman numeral for copper using what I knew about sulfate. Not quite sure what the low is over here. Let's just move that away for right now. Then I had ammonium chloride. Ammonium is a polyatomic ion, so this had to be ionic. I wrote down the charges, and then I worked out the formula, NH4Cl. Phosphorus and chlorine are both nonmetals. Oh, there it is. Phosphorus and chlorine are both nonmetals, so I had to use the prefixes. There's no prefix on mono if it's the first word, but there is a prefix for chlorine, so I put the tri on there, so there we go. And don't forget you change molecules to IDE for the second word. Chlorine monoxide, so that's chlorine and 1 oxygen, and we're done. And then HCl, we have our first acid. Remember, acids start with hydrogen, and this is just chlorine, so we have the hydroblankic acid instead of hydrochloric acid. And then we have a prefix being used, so this must be a molecule. And then we have, this looks a whole lot like that first one, doesn't it? But it's sulfite. Sulfite has 1 less oxygen than sulfate. Magnesium fluoride, magnesium's a +2, fluorine's a -1, MgF2. Sorry about my handwriting there. Let's just do a reveal on the last two. This is 2 nonmetals, so I use the prefixes and I changed to IDE. This is a metal and a nonmetal, so I wrote the charges, accidentally wrote the charge wrong, then I corrected myself, and then I have the other formula. So yeah, that should take you about 3 minutes to roll through these 11 questions. On to the next one. I don't know where number 12 went. It just disappeared. I can't find it. Sorry about that. Same idea. Sodium peroxide. Now, I know this has to be a polyatomic ion because it has a funny name, peroxide. Um, and so one clue you might find out there is something like hydrogen peroxide, and you might work out the formulas. And you know peroxide has to be a polyatomic ion because it's a weird name for not an element. So I wrote down what I know about hydrogen there. Hydrogen's a +1. There's 2 of them. So the peroxide has to be a -2. Since there's 2 hydrogens that are a +1, the peroxide has to be a -2. And then I use that same logic to figure out the sodium peroxide. Sodium hydroxide, sodium hydroxide. I'm just going to keep going. Copper's a Roman numeral 1, so that's a +1. Then we have oxygen. So there's 2 coppers. Ammonium carbonate. That's ammonium, that's carbonate. Enough said. Zinc sulfide. Now, zinc's a +2, sulfur's a -2, so there's only 1 of each of those. If you wrote Zn2S2, make sure you reduce to the lowest whole number ratio for ionic compounds. This is an acid, starts with hydrogen. That's nitrate after it. Nitrate becomes nitric acid. Potassium carbonate, probably one of the most common compounds in our lives. Strontium is a metal, so this is strontium phosphide. And then we have hydrobromic acid, that's a hydro followed by the element bromine. And then magnesium hydroxide. Magnesium's a +2, hydroxide's a -1. Well, I don't know why I'm saying that, we just had to write the name. All right, now we're on to 23 through 33. Perchloric acid. If it's perchloric, It must come from perchlorate. That is one of the polyatomic ions that we asked you to learn this year, so make sure you know that one. It's pretty common. That's aluminum sulfur, so aluminum sulfide. Lead and acetate. These are ions, so I've got to use the ionic rules. Lead's a +2, so I need 2 acetates. Silver bromide. Silver actually is always a +1 charge as an ion, so you don't really need a Roman numeral on there, but you'll see it quite often that silver's got a +1 charge, but silver's always a +1 charge. It's one of the few transition metals that doesn't change. Sodium permanganate, sodium's +1, permanganate's a -1, so it's NaMnO4. Phosphorus and oxygen are both nonmetals, so throw prefixes on both of them. Lithium hypobromite. Now, you're not supposed to know hypobromite. I'm not going to ask that you do. But quite often with a question like this, there's actually a clue given somewhere else in the question. Like it says copper and BrO2. And from this copper and this BrO2, two bros, the two bros tell you that the copper is a +2, and the fact that there's only one copper tells you that bro is a -1. So you can use a clue to like work backwards to figure out some of the weird polyatomic ions. And there's always a clue with one of the weird polyatomic ions. Don't go trying to memorize the 118 polyatomic ions out there. Yeah, 118. Moving on, starts with a hydrogen, must be an acid. That's acetate, so this is acetic acid. Potassium cyanide, +1, -1, already balanced. Cool. Iron 3, so that means it's a +3. Hydroxide's a -1, so there's the formula. And then this one's probably the trickiest of all of the transition metals because oxygen is a -2, and there's only one manganese. That must be a +4 manganese. That's manganese Roman numeral 4 oxide. And what else do we have here? Silicon dioxide, and that's got a prefix, so it just tells us what to do. Lithium oxide, that's a metal and a non-metal, so no prefixes needed. Nitrogen trifluoride, they used prefixes because this is a molecule, so there's 3 fluorines. Iron and iodine, metal and a non-metal, so we got to use the right naming rules. Iron has to have a Roman numeral to tell us its charge, and I got that charge based off of the charges that are implied there. Chromium 3 oxide. Chromium's a +3, oxygen's a -2. There you go, Cr2O3. Copper 1 phosphate. There's only one phosphate here. It's a -3. There's 3 coppers, so that must be a +1. That's where that Roman numeral came from. Calcium chlorate, awesome sauce boss. And that's a 2 nonmetals, so we have to use prefixes. This is the one, 42 probably stumped you because you don't know thiocyanate. But here might a clue be, if it was given like this, you could say, well, aluminum, and there's thiocyanate. Aluminum's a +3. There's 3 thiocyanates, so that must be a -1. So again, with these weird polyatomic ions that you're not supposed to know, they usually give you a clue. And I'm sorry that's not on the review sheet, but it is in here. So those of you who chose to watch this video are getting some intel. And then sodium cyanide and nitrous acid. If that's nitrous, this must be nitrite, and nitrite is NO2. All right, so those are our nomenclature rules. Now we move on to balancing. And yeah, I'm going quickly because you're supposed to already know how to do all this stuff. Balancing, that was a 2211. It was a little bit tricky because oxygen was all over the flippin' place. I'm trying to remember why I decided to start where I did. I had an even number of hydrogens on the left side with 2, but I had 2 and 1, and that was an odd number. So I put a 2 here to get the hydrogens equal, and then kind of looked at what the damage was after I put that 2 there. In number 48, I started off with nitrogen and hydrogen, and then I ended up with a fraction of oxygen, 2.5 oxygen. So I doubled everything to get it. And the red is the final answer. In number 49, I thought I was going to have to double it. So I started off with 2, and then I fixed the phosphorus and fixed things. And then I realized I didn't need to have it doubled, so I reduced it back down. Name of the game there is don't forget to always reduce the ratios to the lowest whole number ratio. Number 50 wasn't too bad. The carbons were a little bit hard to handle. And then number 51, I ended up with 7 O2s at one point, and that threw me off. 7 is kind of a weird number. We don't run into that one too often in balancing equations. And then 52, everyone's favorite, it was already balanced. All right, 53 through 58, we just had to identify the type of reaction. So looking at this one, it looks like it's a double replacement. Yay. This is some sort of combustion. It makes carbon dioxide, so it must be a complete combustion. This has got a single element replacing the element. That must be a single replacement. We have two compounds making two new compounds. This must be a double replacement. I have a compound and a compound making two new compounds. This must be a double replacement. Or acid base. Why is it an acid base? HBr is an acid, hydroxide is a base, and they made water. So when acids and bases react, they make water. That's also an acid-base reaction in addition to just a double replacement. And the last one, we have one compound being broken apart. That's a decomposition. And then the last page for 51 through for 1 through 63, this one took me 10 minutes to do because there's a whole lot of like writing the formulas and then balancing them. And if you write the formulas wrong, you're never going to balance it correctly. The first one though was pretty easy to figure out because it was all these molecules. Don't forget the elements that are diatomic, like oxygen. You maybe said Hoff-Brinkel or Brinkel-Hoff to describe the diatomics. Either way, it's good. Um, and then after you write all the formulas correctly, I came back in blue and wrote the coefficients. Number 60, I wrote the charges on top of each molecule, or ionic compound, I should say, and then worked out the formulas from there. And then once I worked out the formulas, I then worried about balancing it. But again, if you have in one formula, if you have this as a 4, if you make this as a 4, you'd put that as a 4, then you'd have 8 hydrogens, you'd have 8 hydrogens and 8 chlorines, and then you'd hit the chlorines wrong, and then you'd be messing things up. So you have to give your nomenclature skills perfect. Number 61, lead nitrate, +2, -1, sodium phosphate. And then on the second half, we have lead, phosphate, sodium, and nitrate again. So those are the same charges, which is why I didn't write them down a second time. And after I wrote the formulas carefully, I then came back and balanced it. Number 61, zinc is all by itself, so it's just boring zinc with no charge. And then on the other side, it does have a charge. Zinc is always a +2. So there we go. I actually should have noted that in there. Zinc is always a +2 in a compound. Just like silver is always a +1, zinc is always a +2. And number 63, the last one we're doing in this video, strontium hydroxide. Strontium's a +2, hydroxide's a -1. There we go. Hydrobromic acid, it's got hydrogen and bromine in it. Hydrogen's a +1, bromine's a -1. There we go. Produces water. I know how to write water. And strontium bromide, again, +2, -1, so I have 2 bromines. Then I come back and balance the whole thing, and then I stop the video. And now for this part, I am just going to give you a couple seconds with each set of questions so that you have a chance to look at it. So like here's questions 1 through 8. You can pause the video and check your answers. And then here's 9 through 10 and a couple of those others. And again, pause the video and check your answers. 13 through 18 showing up pretty nicely there. Pause the video, check your answers. 19 through 21 showing up easily. Pause your video, check your answers. And 23 through 28, pause, check, and we're back. 29 through 33, pause, check, and we're back. Sorry about the accents. I just go in weird places sometimes. You know what? Oh, watch this. I can make it bigger. Nope, that's smaller, you idiot. That's just barely better. Let's see if I can. Okay. Again, here you have 34 through 39. Pause your video and check your answers. 40 through 44. Pause your video. Check your answers. The balancing equations, we can get all these on one. So pause your video and check your answers. This part you probably knocked out of the park, but just in case, pause your video and check your answers. And then the writing all the formulas down and working it through. There's 59 and 60 right there. And I'm actually have to zoom back out to 200% so that you can see all of that one question. There we go. So there is 61 through 63. And that's the end of Pause and Check. Come back in for the next video in a couple of minutes after I finish working on something. Bye-bye.